Hello, Calc BC. Welcome to Unit 1, Lesson 1. So the way that we organize our lessons in our course is going to be a little bit different from the AP course exam description that's published by College Board. What you see on the screen right now is College Board's Unit 1. And our Unit 1 is only going to have 3 lessons, and it's going to be an overview of the College Board's Unit 1 because you learned all of this material last year if you took Calculus AB. So this first lesson of ours is going to encompass lessons 2, 3, and 4 from the College Board's Unit 1. So that's going to be defining limits and using limit notation, estimating limit values from graphs, and estimating limit values from tables. And this overview is also available on your Schoology page. You can see we're gonna get into more of this stuff in the next 2 lessons as well. And as we go down here, you can see that each topic comes with an enduring understanding, a learning objective, essential knowledge. And I'm not gonna read this to you, but you can go through here and read that on your own if you'd like to see what we're covering. So there's all of our topics for today's video. So I'm going to pause recording for just a second so I can get the notes ready, and then we're going to start to take notes. All right, so here are the notes for our Chapter 1, Lesson 1, Finding Limits Graphically and Numerically. How this is going to work is I'm going to write the notes on this paper as I'm teaching it in the video, and I'd like you to just write it on your own paper. I'm also going to upload a blank copy of the notes to Schoology. So if you would prefer to write on the notes sheet and you have your own printer, you're welcome to do that. You can print that out now, pause the video, and do that before we continue. Otherwise, you can just do this on your own line paper. But make sure you are taking your own notes, because at the end, you will have to submit your own handwritten version of the notes, either on line paper or on your printed copy on Schoology. So make sure that you're doing that as we go, all right? So let's take a look. Example 1, use your calculator to complete the table and then use the results to estimate the limit. Then graph the function to confirm your results. All right, so we're talking about limits here. This is limit notation. LIM as x approaches -3. So this is the limit as x approaches -3 of this expression right here. And what we are really getting at is, as we approach -3 from the sides, what y value are we kind of pinching towards? So as x approaches -3 is all about the x-axis, the answer is going to be all about y values. So let's see what we can do here. We first are just going to complete the table as the directions tell us. So I'm going to pull up my calculator here. Of course, there's a nice glare. Hopefully you can see this. I'm going to go to y equals and just start typing this in. So we have the square root of x plus 4 minus 1 over x plus 3. And I know some of you might be screaming at me because I didn't use the fraction notation. This works just as well. And back in the olden days, we didn't have these fancy graphing calculators. I had a TI-83, and there were no fraction modes. I don't even remember where it is. It's like alpha something. Yeah, alpha y equals. If you want to use it, it's number 1 in alpha y equals. But anyway, that's what we're looking for. So I'm going to go to table setup, so second window. I'm going to change independent to ask instead of auto. And then if I go to second graph to the table, I can type in the x values that I want. So I'm going to type in -3.1, and I'm taking the x values straight from the paper. -3.01, -3.001, -2.999, etc. All right, so there's my answers, and now I'm just going to write these in. So we had this, this, there we go, and okay. So there's our table of values. The question says, after we complete the table, use the results to estimate the limit. So I want to know what y value or f of x value does it look like we're approaching from the left and from the right of -3. So right in the middle here is x equals -3. You can see our x values are getting closer and closer to -3 from the left and from the right. So what are our y values getting closer and closer to? Hopefully you can see that it looks like it's 0.5. And this is different from the actual function, right? So the function f of -3, if we plug -3 into this, what do we get? -3 plus 4 is the square root of 1 minus 1, so we get 0 over 0, right? So that does not exist. The function doesn't actually exist at -3, but the limit does. It still approaches something from both sides. You might remember that from AB. So now I'm going to go and actually look at the graph here. And you can see it's a curve. It starts and then it just keeps going forever. So I'm going to sketch this quickly here. And we have a point at -4, 1. Let me just check that. -1 over -1, yeah. Yes, it is at -4, 1. And then there's going to be a hole at -3, 1/2. We just figured that out over there. But everything else exists. So it's going to look something like that. The hole doesn't necessarily show up on our graph, on the graphing calculator. That's just an unfortunate reality of using these graphing calculators, is that they don't show specific details like that. All right, so that was the first example. We have one more example with a table. And I'm just going to start to fill this in here. So if I type in sine of 4x over 4x on my calculator and I go to the table, I'm going to want to know what x values do we want to put in. We're going to want to get closer and closer to x equals 0. And so what I usually do, pretty standard practice, is to add 0.001, add 0.01, and add 0.1. And then subtract those same values below. So we'll end up with 0.001, 0.01, 0.1, and then -0.001, -0.01, and -0.1. And if you go in and try this, I encourage you to save time in this recording. I'm just going to write out what I got for my f of x values. Okay, so this is getting pretty, it's increasing towards 4. And then on this side, if I look at it from the right, it's also increasing towards 4. So this answer actually is 4. And if you graph this, it looks a little bit crazier than the first one. We have a hole at 4, because again, we're dividing by 0. And then it just kind of does this crazy thing. And you'll see that if you graph it on your graphing calculator. And yeah, so that shows us graphically that the limit is approaching a y value of 4 from the sides. Now, both of these methods, the graphing method and the table method, are not exact, right? Like if we zoom in a little bit further here, maybe the graph does something crazy. Maybe the function does something crazy. We just don't know. But that's the best that we can do to estimate the limit. That's why it's called estimating the limit in the example. All right, so in the next couple problems, we're just going to sketch the graph and use it to find the limit. We're not going to worry about the table. So the next one is a piecewise. Now, piecewise functions are really not that bad, but it seems like if you haven't seen it for a while, it always throws people for a loop. But let's take a look. So the function is defined as x squared plus 1 whenever x doesn't equal 2, and 3 when x does equal 2. So I want to start with this second part. It's going to be a little easier to graph. It literally just means whenever we have an x value of 2, the y value is 3. It just wants a point at 2, 3. And then the first part means when x is not 2, so anywhere else, we're going to follow the curve x squared plus 1. All right, so x squared plus 1 is a quadratic. It has a vertex at 0, 1. You can use your calculator to sketch this if you want. But let's try plugging in some points. So if we plug in 1 plus 1, we'll get 2. 2 squared is 4 plus 1 is 5, so it's going to be up here then. But remember, it doesn't actually exist at 2, 5. So it's going to go like this. And then over here, it's going to mirror the same thing, but it will exist. Okay, so we've got a nice quadratic, a nice parabola with a hole at 2, and at 2 it equals 3 instead. So we want to know the limit as x approaches 2 from the sides. Remember, the limit doesn't mean what's the value of the function. It means what is the value that the function's approaching from the sides. Horizontally from the sides as we get closer, what vertical value are we approaching? And the vertical value we are approaching here is 5, because if I plug in 2 into this top equation, I get 5, and that's what we're approaching from the sides, a y value of 5. Right, in this next one, let's take a look at the graph. We have an absolute value of x plus 3 over x plus 3. If you start plugging in values here, you plug in 0, for example, we'll just get 3 over 3. So at 0, it equals 1. We plug in 1, we get 4 over 4, it equals 1. We plug in -1, it equals 2 over 2, which is 1. If we plug in -2, we get 1 over 1, which is 1. If we plug in -4, now we have -1, absolute value of -1, so 1 over -1. So at -4, we're down at -1. Basically, what you'll find out is that anytime we plug in a number bigger than -3, the y value is just 1. And anytime that we plug in a number smaller than -3, the y value is -1. And you can graph this one as well. Absolute value on the calculator is, let me see if I can remember. Yeah, math. So you press math, you go over to the num tab, and it's number 1, ABS, x plus 3 over parentheses x plus 3, 6, and you'll see the same graph that we just sketched. It does not exist at -3. There's 2 holes because you can't divide by 0, and -3 plus 3 is 0 in the denominator there. All right, so we want to know, what is this approach from the sides? Well, from the left, it looks like the y value is just sticking at -1, and from the right, the y value is approaching +1. So it's approaching 2 different values, so the overall limit does not exist. You could say it is approaching 2 different values. All right, so that's that. And that brings us to the last example. So I'm going to flip this page over here. Make sure you have that down. Last example, but it has a couple of different steps here. But let's take a look. There's already a graph of f shown on the right, and we want to decide whether the value of the given quantity exists. If it does, find it. If not, explain why. All right, so let's take a look. The first 2 questions here are not limits. They're just f of 0 and f of 1. So when x is 0, what's y? So if we look for an x value of 0, we have a hole up here, but we do have a point down here. So the y value is -4. And we want to know f of 1. If we look up and down when x is 1, there's a hole, but there's no points. So this does not exist because there's no y value when x equals 1. For letter C, then, this is our first limit. So now we're looking to limit as x approaches 0 of f of x. We already did f of 0, but now we're doing a limit as x approaches 0. Now from the left, we're approaching something between 0 and 1, and from the right, we're approaching a y value of -4. So this does not exist because it approaches two different numbers. Letter D, as x approaches 1 of f of x, the limit as x approaches 1. So we already said that the f of 1 doesn't exist, but from the left we approach a y value of -1, and from the right we approach a y value of -1. So the overall limit is -1. We're approaching -1 from the sides. Okay, letter E, the limit as x approaches -3. Okay, so -3 is all the way over here. From the left, it looks like we're approaching positive infinity, and from the right, it looks like we're approaching negative infinity. So overall, that limit does not exist. Approaches positive infinity and negative infinity. And the last one, limit as x approaches 5 of f of x. And if we look up here, as we approach 5 from the left, we're approaching a y value of positive infinity. And from the right, we're approaching a y value of positive infinity. So we can actually write that that answer is infinity or positive infinity. So there's some good practice of limits, all right? Hopefully that all makes sense. If you have questions, please feel free to reach out to me. You can bring me questions in class. You can email me. You can attend virtual office hours, whatever is best for you, all right? Don't forget to submit your handwritten version of these notes on Schoology and then work on the worksheet. Thank you very much, and I look forward to more lessons.